a special element in the periodic table named after the great scientist Albert Einstein. However, even Einstein himself would have had difficulty fully grasping the difficulties and challenges scientists face when researching the element named after him. This is the element Einsteinium. For the past 70 years, researching Einsteinium isotopes has remained a major challenge, as they are either extremely difficult to produce or have a half-life that is too short. This element does not occur naturally on Earth and is only created artificially through nuclear reactions. The element Einsteinium has the chemical symbol S, atomic number 99, atomic weight 252, and a melting point of 860 degrees Celsius. In December 1952, Albert Ghiorso and his research team discovered the element Einsteinium while analyzing radioactive dust particles from the world's first hydrogen bomb, thermonuclear bomb, test. Codenamed EV Mike, this nuclear weapon test with a yield of 10 megatons was conducted in the South Pacific region in November 1952. The explosion produced Einsteinium-253, an isotope with a 20-day half-life, named after the genius physicist Albert Einstein. It was the seventh transuranium element to be discovered, but this information was kept secret until 1955 by order of the U.S. military due to the extremely tense wartime situation. The chemical properties of Einsteinium are characteristic of a heavy actinide element, with its characteristic oxidation state being +3. It is the first element in the actinide series that can exhibit the +2 oxidation state. The actinides are a group of 15 metallic elements located at the bottom of the periodic table, characterized by having only 2 bonding electrons instead of 3. Einsteinium is produced through a long chain of nuclear reactions, in which each isotope in the chain is bombarded with neutrons, and the resulting isotope then undergoes beta decay. In 1961, a significant quantity of the isotope was produced, sufficient for chemists to isolate and study Einsteinium-253. However, for most of the time since its discovery, no significant quantity of Einsteinium has ever been produced. It is one of the heaviest and most elusive elements in the periodic table. For the first time in decades, chemists have successfully studied the element Einsteinium. Island of stability. This element does not occur naturally on Earth and can only be produced in extremely small quantities in specialized nuclear reactors. It is also very difficult to separate from other elements, is highly radioactive, and decays rapidly, posing a major obstacle to the research process. However, recently, researchers from Lawrence Berkeley National Laboratory at the University of California, who conducted the first experiments on Einsteinium back in the 1970s, have successfully produced a pure sample of Einsteinium weighing 233 nanograms. In this way, they were able for the first time to uncover some of the fundamental chemical properties of the element Einsteinium. Researching this issue is an immense challenge. For a long time after its discovery, physicists had virtually no understanding of the element Einsteinium. According to co-author Corey Carter, who is currently an assistant professor at the University of Iowa and was formerly a scientist at the Buckley Laboratory, it is difficult to study Einsteinium, primarily because of its position in the periodic table. Like other elements in the actinide series, Einsteinium is produced by bombarding a target element. In this case, curium combines with neutrons and protons to form heavier elements. The research team used a specialized nuclear reactor at the Oak Ridge National Laboratory in Tennessee. This is one of the few places in the world capable of producing the element Einsteinium. However, this reaction was created for the purpose of synthesizing californium, an important element often used in nuclear power plants. Therefore, it only produces a very small amount of Einsteinium as a byproduct. The extraction of a pure Einsteinium sample from californium is a significant challenge, primarily due to the similarity in the properties of these two elements. This means researchers have only obtained a small sample of Einsteinium-254, one of the most stable isotopes of this element. According to Corey Carter, it is an extremely small amount of material, invisible to the naked eye, and the only way to detect its existence is through the radioactive signal it emits. However, creating Einsteinium was only half the problem, the other half was how to store it. Essentially, Einsteinium-254 has a half-life of 276 days. It decays into berkelium-250 and emits gamma radiation that is hazardous to humans. Therefore, researchers at Los Alamos National Laboratory in New Mexico designed a specialized sample holder called INBA, intended to store Einsteinium and protect the scientists at the Buckley Laboratory from the radiation it emits. However, the decay of Einsteinium-254 also poses significant challenges for researchers. It decays continuously, causing the sample's mass to diminish by approximately 7.2% each month. This compels scientists to perform meticulous calculations in order to plan their experiments with precision. The team at Buckley Lab was already well versed in handling short half-life elements. However, they had only just begun this work immediately prior to the pandemic's outbreak. Consequently, a precious amount of time was lost, preventing them from completing all the experiments that had been planned. The main finding of the study is the measurement of einsteinium's bond length, the average distance between two atoms when they form a bond. This is a fundamental chemical property that allows scientists to predict how einsteinium will interact with other elements. They discovered that einsteinium's bond length does not follow the general trend of the actinide elements, the special group of radioactive metals located at the bottom of the periodic table. This is something that had been theoretically predicted but never before proven in practice. Compared to other parts in the Achenae series, einsteinium also exhibits a very distinct luminescence pattern when exposed to light. The research team describes this as a previously unknown physical phenomenon and believes that further in-depth experiments are necessary to determine the cause. This new research also opens up the possibility of producing einsteinium more easily in the future. Specifically, einsteinium can be used as a target element for synthesizing heavier elements, including undiscovered ones such as the hypothetical element 119, ununenium. In summary, einsteinium is a remarkable chemical element, not only because it is named after the genius physicist Albert Einstein, but also because it is one of the synthetic superheavy elements that do not occur naturally on Earth. It is an extremely mysterious element in the periodic table, and also incredibly fascinating for its capacity to hold the universe's immense secrets and potential. It is a hypothetical superheavy element, named not only to honor the physicist, but one that itself exists only in theory. This is a hypothetical element, not only because it is named after a physicist, but also because it is itself entirely a product of hypothesis.